A supernova is one of the most violent, energetic events in the universe today. You are blowing up a star. There's no way to describe that kind of energy.
Some supernovae are so powerful, they are second only to the Big Bang itself for energy and sheer power. They are so magnificent, they can outshine an entire galaxy of 200 billion stars.
Supernovas can create one of the weirdest objects in the universe. A pulsar. Pulsars are intensely magnetic stars. They fire out beams of electromagnetic radiation that sweep across space.
There are few things in the universe more dramatic than a pulsar. Imagine a ball about 10 miles across, rotating hundreds of times a second. With a density that's almost unimaginable, 1 cubic centimeter of this material would have as much mass as Mount Everest.
You would feel a gravity that is millions of times what you're feeling sitting on the surface of the Earth. You wouldn't just be crushed flat by this. You would be crushed into a paste that is only a few atoms thick.
Anything that orbits a pulsar too closely risks being torn to shreds. This is the Black Widow pulsar. It rips through our galaxy at 600,000 miles an hour. The shock wave is so vast, our telescopes can detect it 5,000 light years away. Traveling alongside it, a brown dwarf, bigger than a planet, smaller than a star. The pair are locked in an orbital dance of death.
The Black Widow in some sense is like a vampire, sucking the lifeblood from this brown dwarf star, eating away at its hydrogen and helium fuel.
Radiation blasts the brown dwarf's gases into space. A pulsar just 10 miles wide is destroying an object bigger than Jupiter. Eventually, the brown dwarf will evaporate. A single pulsar has immense destructive power. But two pulsars together can change the shape of the universe. This is the only known double pulsar system in our galaxy. Orbiting at 700,000 miles an hour, their speed and mass make them spin chaotically.
It's incredible to think of the enormous forces gravitationally that these two stars exert on each other, causing the whole geometry, the architecture of the system to change and spin around like a top on the table.
The gravity of the heavier pulsar makes the smaller one wobble erratically. It whips around so violently that the whole star almost tips over, just like a spinning top. It can't last forever. 85 million years from now, the two pulsars will merge to form a vast gravitational abyss. The universe's ultimate monster, a black hole. A black hole, the most extreme object in the universe. At its center, the laws of physics break down. Time comes to an end. Gravity is infinite.
A black hole is a bottomless pit of gravity caused by the death of a star. There is nothing in the universe more mysterious than how black holes work.
If you want to talk about extreme orbits and extreme gravity, you're talking black holes. That is at the top of the list. Nothing has stronger gravity than a black hole. It is the mass of something like the sun or more, compressed down into a ball that's only a couple of miles across.
50 years ago, black holes were dismissed as science fiction. But not anymore.
Now we see them at the center of galaxies, wandering through outer space. Black holes, we now know, are central to the evolution of the universe.
We now think there may be 100 million black holes in our galaxy alone. An encounter with any of them leads to oblivion. This is one of the largest and hottest stars in the universe. It's 20 times more massive than our sun and 10 times hotter. Stars like this never live long, but this one is locked in a diabolic waltz, trapped in the grip of a black hole. The gravity here is so powerful, the star orbits at 500,000 miles an hour. The black hole sucks the star's outer layers into a vast, swirling disk. A disk so hot, it blasts out X-rays 1,000,000 times more powerful than our sun.
This configuration of star orbiting around a black hole is extreme and it's unstable. First of all, the black hole is eating away at the atmosphere of its companion star, but the star itself is unstable. It will one day undergo a supernova and perhaps leave a black hole in its wake. And then we'll have two black holes rotating around each other, one of the rarest sights in the universe.
Eventually, these black holes will merge to create a new, larger monster, and the cycle of destruction will continue. But this black hole is small. Other black holes take violence to a whole new level. In 2011, astronomers witnessed one of the biggest explosions ever recorded. A flash of radiation brighter than 100 billion suns. A gamma ray burst. It was a spectacular event. The burst came from a supermassive black hole at the center of a distant galaxy. It had been dormant, but something had shocked it back to life.
If you pass by the event horizon, an imaginary sphere surrounding the black hole, that's the point of no return. It's like the ultimate Roche motel. Everything checks in, nothing checks out.
Several stars were orbiting the black hole at a safe distance. Then one of them got too close. The sleeping giant suddenly awoke. Immense gravitational forces stretched the star to its breaking point until finally it was torn apart. Debris swirled round the black hole, heated to millions of degrees. Two giant jets of gamma rays blasted into space at the speed of light.
A black hole has torn a star apart, swallowed up half of the material of the star, and ejected the other half in an event that is among the most violent things we have ever seen in the history of astronomy.
The event was so violent, we saw it from Earth 3 billion light years away. Black holes can suck in planets and rip apart stars. But gravity doesn't always pull things in.
Any high school student knows that gravity sucks. It pulls, it never pushes. But it's actually more complicated. That's true when you just have two objects. But the minute you have more than two objects, strange things can happen, and gravity can actually push you away.
You can get very close to a body, but if you come in at just the right angle and just the right speed, instead of colliding together, one object can slingshot the other one away.
Recently, scientists discovered stars hurtling away from our galaxy at incredible speed. Normal stars don't do this. So what could accelerate a star to hypervelocity? The answer was a surprise.
You can only eject stars at these very, very high velocities, so close to 700, 800, 1,000 kilometers a second. You could only eject these with interactions with the supermassive black hole.
Each hypervelocity star was originally one of a pair of stars orbiting a supermassive black hole. When they got too close, gravity pulled them apart. The black hole catapulted one star out of the galaxy at 2 million miles an hour. Eventually, the other was sucked in and destroyed.
The interesting thing here is that you can get a complete redistribution of stars. So you have stars that are in the center of the galaxy and suddenly they're ejected out into intergalactic space.
And it's out here in deep space that orbits are at their most powerful, smashing entire galaxies together to create the structure of the universe itself. Across the universe, extreme gravity is a force of destruction. The orbits of planets and stars can be chaotic, unpredictable, and violent. But on a truly cosmic scale, gravity is no longer just a destroyer. It also creates new worlds. These are galaxies, giant spinning clusters of stars, gas, and dust, 100,000 light years across. Galaxies orbit each other in the same way planets orbit stars. Gravity pulls them together. Their speed keeps them apart. But ultimately, gravity always wins. Entire galaxies smash together.
One of the most spectacular events in the universe is when galaxies collide. You're talking about hundreds of billions of stars, 100,000 light years across. Two of these things slamming into each other.
Collisions between orbiting galaxies take place over millions of years. Gravity slowly pulls them together.
And you get these two galaxies that merge like two fluids mixing together, and you get long tidal tails as they pass through each other, but then gravity brings them back together again, and in the end, you get a full-fledged, more mature, larger galaxy than you had originally.
On this intergalactic scale, gravity and motion are no longer destructive forces. Now, they trigger the creation of life itself.
You would think a galactic collision would be incredibly destructive, and in one sense it is, but in another sense it's a very creative force.
Colliding galaxies smash vast gas clouds together. Huge shock waves rip through them, squeezing the gas. Then something amazing happens, the birth of countless stars.
It's incredible to think about two galaxies that gravitationally attract each other and collide. What could be more destructive? But in fact, there's a power of construction in such mergers, because as two galaxies come together, the gases are compressed, and sometimes the gases are compressed so much that you get the birth of stars and the associated planets around those stars. And so in the titanic collision between two galaxies, you can get the birth of stars and planets and perhaps eventually life on those planets.
Sometimes these collisions trigger a chain reaction. Two spiral galaxies in mid-collision, creating stars and planets. But this time, there's a difference. Some of these new stars are massive, unstable, and short-lived. They explode. Each explosion blasts out new shock waves and triggers the birth of even more stars. Astronomers call this a starburst. It's the ultimate example of gravity's creative power.
A starburst galaxy is one that is creating stars at a much higher rate than we usually see in normal galaxies. And so it's amazing that you can have such a beautiful creative process coming out of something so violent and destructive.
Gravity and motion, the two forces that give birth to every new star, also weave together the fabric of the universe itself. Our cosmos is not random. It has structure. The universe is a vast three-dimensional tapestry. Each of these threads and filaments contains billions of galaxies. It's the scaffolding that holds everything together. The cosmic web.
And we think about scaffolding of a building, it's just sitting there static. But in fact, this scaffolding is quite dynamic and quite amazing because all of the constituents are moving around at very high speeds, crashing into one another. Galaxies, stars, black holes, supernovae, all in this tremendous cosmic dance.
The cosmic web is incomprehensibly vast. Each thread is full of motion. Galaxies form, orbit, and collide. Countless billions in a constant stream. Every filament is a galactic freeway with an endless flow of traffic. Each point of light a galaxy. It's rush hour 24/7. And sometimes there's gridlock. Every billion light years, several filaments join to form a knot. Whole clusters collide to form some of the largest structures we know of, superclusters. This is one of them, Abell 2744. 5 orbiting galaxy clusters crashed together in the single biggest cosmic pileup ever discovered. Gradually, the 5 clusters merged and fused to form a single giant supercluster 6 million light years across. The incredible power of orbits can literally tie the universe in knots.
Structures in the universe have evolved over billions of years through their orbits and their mutual gravitational attraction, and they've built up into larger and larger structures, and it's all thanks to these same attractive forces that bring them together, but can also tear them apart.
Again and again, we discover orbits dominating the cosmos.
The atom is the basic unit of chemistry. In the same way, the orbit is the basic unit of the universe itself. If you understand all possible orbits, you understand the dynamics driving the universe.
Orbits have created a cosmos full of richness and complexity.
Orbits are changeable, they're chaotic. Things that we never thought were possible are in fact possible.
From the smallest scale to the largest scale, it's the gravitational interactions and collisions that actually make our universe the beautiful place that it is.
And behind it all is a curious paradox.
Extreme orbits mean variations, collisions. That seems very destructive. But also extreme orbits mean colliding galaxies, collapsing dust clouds, the very creation of life as well as destruction.
Orbits are the driving force behind this never-ending cycle of creation and destruction. They're at the very heart of how the universe works.